Okay, so the first one we have to know for the exam is the angle at center equals 2 times angle at circumference. Okay, so with this, we have the center of the circle, we call that O. And then we're looking at the angle at circumference. So what this shape looks like is it goes to the circumference and then to the other side and joins. So you've got two lines from the center to the circumference, and then from those 2 points, we join to the other side. So it'll look like that. Just actually use straight lines on that. Over there. Okay, so you're going to see this arrow shape.
Mm.
So when you see this arrow shape, then you know that the angle at the center is equal to 2 times the angle at the circumference. So we have the arrow shape, there's the center. So if this at the circumference is x, then the angle at the center is 2x.
Right.
So how we would say it is if we had for these points A, B, and C, then we would say A. Okay, so if we were looking at A, we could either call it A1 or we could call it BAC. BAC, angle BAC is equal to, now, if this is X, it's basically a half of the center, isn't it? So angle BAC is equal to a half, yeah, BOC. BOC. And your reason, angle at center equals 2 times angle at circumference. Quite a long one. Look at this quickly. Yeah, so we have to write the full thing, 2 times angle at circumference.
Okay.
So I'll do that. So either that or angle BOC is equal to 2 BAC. So these are the same thing, just the other way, just different ways of doing it. So let me write this full one properly. Angle at center equals 2 times angle at circumference. Okay, now these other 3 drawings are exactly the same theorem. It's the only difference is where we put the angle at the circumference. So I could still have this BC. So I still have that part there. So in other words, let me just highlight that. So we notice this isn't really changing. but where it's changing is where I'm putting the A. Okay. So where I'm putting the A. So let's say that I was to put the A over here, right? There. You get a very different shape, but it's the same, exactly the same theorem. So it'll look something like that. So you have this bow tie, but instead of your angles in the same segment where you have the bow tie going to all parts of the circumference, it's a little bow tie, and kind of in only a quarter of the triangle, but it's exactly the same. So if this is our x, because that's the one at the A, then this is going to be 2x. And you write it exactly the same as I've put it up here.
Right.
Then, so that would be the center. Okay, the last one. Okay, so if we move it anywhere along this circumference here, we're going to get one of those shapes. But what happens if we put the A between B and C? Yes. Now A. So we've got our O and our B, our C. So those haven't changed. Still the same. But now my A is the circumference. Okay. Okay, now for this one, our X is here.
Right.
Okay, so it's still between AC and B. So we notice here we have AC and BA. X is still between AC and BA.
Right.
But now we don't want to confuse it and say that this is our 2x, because that's not our 2x. So the major difference between this one is because you see that BOC actually looks smaller than
Yeah.
BAC.
So it's the top, the 2x then.
Very good. Yeah. Okay, so that one's a bit trickier to see, but we just got to be able to spot them in the diagram. So if you have something like this, and they may have a center O, they could have a number of different lines. But yeah. So that's center O. There could be a number of different ways of doing it. Okay, so in this case, you've almost got two of them. You just got to remember, if that's X, this will be 2X here. And if this is Y, this is 2Y. Does that make sense, or should I draw it a little bit differently? Maybe I should.
No, that does make sense. Yeah.
Okay, cool. Let me just highlight. Okay, so that one, and it's that one equal. It's double. And then
Right.
y and just y. Okay, so we notice that it's the one on the other side. So we have x there, then 2x, it's on the other side.
Okay.
Same here. X here, it's on the other side. It's not inside, it's on the other side.
Other side.
Okay, so that's the first one. Angle at center equals 2 times angle at circumference.
And circumference.